What
Yes,
what
sir.
important things we have seen in the last session?
We discussed about global grid system and local.
Okay,
Sorry,
global access system,
global
local
access
access
and
system.
local access, sir.
Okay, and
And combined grid system.
okay, combined grid
Natural
system.
access.
Yes, Ashok sir.
Natural access. Three accesses we have discussed.
Yeah,
Global, local, and
natural. Okay, these
natural.
three types of access system we have seen, and along with that,
We have
we have
covered the two
started
types of
a new
grids.
exercise.
Yes.
Yeah. So they are actually the objective of taking this exercise to validate the software for some important actions and some important results. Along with that, we have to learn, means side by side we have to understand so many commands and options through which how you can prepare the model. Okay, so lot of things we have to learn in this exercise, that is what validating the software. Okay, so in the last session we are going to, means we actually trying to model as per the given example, and let me show you. See, we have prepared this model of the staircase in respect of your question, where we have to find out the forces in the member of the truss. I hope that you all have done this kind of example in your academics, where the objective was to find out the forces, actual forces in the member of truss. So here we are trying to do the same thing, but we are looking whether your software is giving the right result or not. Okay, so as much as possible we are trying, like we have, as as given, as per the given question and given example, we have modeled this truss. Okay, and one more important things we have learned in the last session, how you can divide the frame. That will come again in the command section, then where we will discuss so many options and commands and settings in this software. So there the editing option will come in detail, but right now whatever the things which is required to complete this exercise we will learn time by time. Okay, so we have seen that what how you can divide the frame. I left the last session with the thing that we will discuss about the selection methods. Got it? So as I told you in the last session, when you are going to practice with the software like ETABS software, so your concentration should be on bottom left and bottom right. Why? Bottom right we will see later, but bottom left is why whatever you are doing over your screen and whatever the things in selection, that will be represented by left bottom side. Like suppose nothing is in selection, so what, there is no anything here, elevation view, only that it is given what actually you are looking, that is actually present here. But see, suppose I am selecting this frame, so what is showing that like one frame is in selection. If I am selecting like this joint, so see what is saying that one joint is in selection. So we are talking about like what is the selection procedure and what is the selection criteria and what are the different options of making the selection. So actually, like if you are clicking over the member or over the joint, that will be selected. Like see, one joint and one frame is in selection. This is the one way. Another way how you can make the selection, like if you are dragging from right to left, what if you are dragging from right to left, so whatever the things which is going to be cut by this rectangle or square, whatever this action, uh, that will be in selection. Whatever the things which is going to be intersected by this square or rectangle, whatever, okay, these that will be selected, plus whatever the things which is going to be completely inside of this box will be selected. Not getting, try to understand. Two criterias are there. When you are dragging from right, once you have to click at any point, being your
Yes, sir.
means mouse to be pressed like drag it.
Drag.
Yes, drag it, and when this box is going to be cut your element, that will be selected.
Yes.
In addition to that,
Yes.
whatever the things which is going to be completely come inside of this box, that will be selected. Two
Yes.
criteria are there. So
Yes.
see
One is
here
click.
what.
Other is drag and click.
Yeah, you have to drag it, and whatever things which is going to be cut by this box, that will be selected. Here only the two frames which is going to be cut by this box, that's why that is in selection. So here what is you are getting, two frames are in selection, very first thing. Second, if you are dragging from right to left, and see whatever the things which is going to be cut by this box will be selected. Okay, good. Next, the things which is completely coming inside of this box, that will be selected. So see here how many frames is going to be cut by this box. This one, this two,
Three.
this three, and this four, I think, sir.
Four.
How
Four.
many? Four. In addition to that, look at this. This joint is completely coming inside of this box, right?
Correct.
Hello.
Yes, sir.
So it
Yes.
is going to be
Yes.
selected. See at this time what results you are getting? One joint and four frames are in selection. Are you getting or not?
Yes, sir.
Okay.
Yes. Yes.
Similarly, when you are dragging from left to right, so what will happen? Whatever, see, whatever the things which is going to be cut by this box, it is not done by as previous case. That element will be selected. That kind of case will not be here. See, nothing is in selection. Is there any?
No, sir.
No.
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 No, that is the case only when you are dragging from right to left, so that element will be in selection. See, 1, 2, 3, 4. So it is what? 4 frames in selection. Okay. But what is the use when you are dragging from left to right? So for this case, when you are dragging from left to right, only the things will be in selection which is completely coming inside of this box. Right?
Sir.
See, when I'm dragging
Okay.
like this,
Right.
what things is completely coming inside of this box?
Joint, sir.
One joint.
Only the joint, so that's why one joint in selection. Close this. See, I am dragging from like this. Yeah, too many members are going to be cut by this box, but that is not useful. Actually the thing is what things are completely coming inside of this box. Can you guess? Can you tell me?
One frame, two joints.
Very good. One frame, two
Yes.
joints is coming inside, so that's why you are getting two joints, one frame. Is that all okay or not?
You're right. Correct.
Right,
Okay.
right, sir.
Just clear these all things. This is very important. One more thing we have learned in the last session, like joints. Okay, sorry, support conditions. So there are three support condition: fixed, roller, hinge support conditions. And the method of assigning the support condition is what you have to, like, suppose select the joint, whatever the way that you want to prefer, like just click over the joint. So that is the one way. Another way, the when you are dragging like this, so it is going to be selected. Got it? In this way, so select the joint by any way, like select this. So two joints are in selection at a time. It is not the case like every time for only for one joint you can assign the support. Too many in once. It depends on you over what number of joints you want to assign the support. That doesn't matter. Okay, so select the joint, select the joint. After making the selection, then go to assign, then go to join. This is the assign work to a particular thing, like joint, frame, shell, whatever, to a particular element. If you want to put anything like loading or like support condition, any labeling, so you need to go to assign option. You are going to put something over that, so you have to go to assign. Then in assign, so many things are there that all things will come time by time. So the first thing is join. In join, the restraint is there. Go to restraint. Once you click over the restraint, so these are the what, translational restraint, rotational restraint. Restraint means what? That is what support against the reaction is what? Reaction is what? Can you guess? Where you will get the reaction? Where there is a restraint against the movement. wherever there is a restraint against the movement on that direction or that direction, you will get the reaction. So suppose the ball is there, that can move in this direction, that can move in this direction, that can move in that direction, that can move in that direction, in all four direction, in plane direction it can move, but it cannot move in downward direction. That's why there is a restraint in this direction. So that's why we will get the reaction. I hope you all are know about this concept, right? Hello.
Yes, sir.
Okay, so that is what the restraint. So for the fixed support, complete restraint will be there, a fixed thing, fixed. So no movement in any direction. So all in all direction it is restrained, it cannot move. In hinged, rotation is allowed, only the translational movement is restrained. In the roller case, only the vertical direction is restrained. Okay, the case that I have that I have discussed just now. And the last one is the none. Suppose I have to assign for all these joints, like hinge support say apply, so the hinge support has been assigned. Are you getting or not? Hello.
Yes, sir.
Good. Yes. Now let's drag it from left to right like this, and I don't want to have anything over these joints. Just says none. So no restraint is there any. If you are not means it is not clear to you about this, so don't worry. Just look at the diagram, and accordingly you can decide. So check this and say apply. Sorry, none. Say apply. So nothing will be there. Okay. After this, okay, our model is now ready. Everything is now ready. All the members are separate member. All the members are connected at their ends. Every means almost all the assumptions of analyzing the truss is now okay. Now next will be what? The question. Okay. Now next we have to assign the loads. So as you know that there are three types of the load. There are three types of load. One is your point load, and that all kinds of all types of loads are available in ETABS software also. So number first is your point load. Number first is what? Your point load. If you want to assign a load over a particular joint or a particular point, so we'll assign the point load, that will be in kilonewton, you all know. There may be a second type of the load, that is line load or uniformly distributed load. The load that is running over the particular length or a particular span, that we are going to call as uniformly distributed load. Then another type of the load is what? Uniformly, can you guess what is it? Hello.
Varying load.
Uniformly varying load. It is uniformly varying load. Uniformly increase is there, but it is what? The uniformly varying load. This kind of load will be there. Uniformly varying load. It is what? Uniformly distributed load. It is what? Point load. And fourth one is what? Your area load. Your what? Area load that we have to assign over the slab. So point load, uniformly distributed load, uniformly varying load, uniformly distributed over the area load. Okay, its unit is what? Its unit is kilonewton force. It is what? Kilonewton per running meter length. Uniformly varying load is also kilonewton per running meter length over a length. This is what? Kilonewton per meter square. Okay, so this is what about the loading. So these all options of loading are available in your software. But for instance, and for this proposed example, we have to assign only the point load over the joints. So here, just go back to your ETABS and look at carefully important points we are going to cover. Okay, so first drag from left to right. So this joint is selected. Okay, first come to this side. Drag it from left to right. Okay. One more thing. Before of assigning of the load, after the after the completion of the modeling, first go to check your model whether the modeling is correct or not. Very important thing I would like to share. Okay, in every step or at every stage you have to do three things in the software. Like what it is, like suppose if you are talking about the modeling, okay, so suppose I have to perform the modeling. So before of the modeling something will be there, that is what settings. Before of modeling something will be there, that is what the first step will be. What before the modeling, all the definition you have to set. Like suppose I have to create a model of any particular building, so I need to what define the section size, define the material properties, and define the load patterns, and so many things are there that we will discuss everything. Okay, so before, without of defining all those things, without of setting all those things, I can't proceed for the modeling. How I can put the column, how can put the beams of required section size, of required material properties, right? So then once it's done, I have to go to perform the modeling. Once the modeling, first second is modeling, after the modeling is what, there will be the check. So with every step there will be the three things will be associated, like setting, then action, then check. So for modeling, setting will be there, then modeling will be there, then check will be there. For analysis, before of that some setting will be there, then you have to perform the analysis, then you have to check, then you have to verify whether the analysis is right or wrong. Check will be there, that will do. Then before of the design some setting will be there, then you have to perform the design, then you have to go to check whether the design is right or wrong. Can you guess? Can you tell me how many steps will be there with every action?
3.
3. Chandradev, Asif.
Sir,
Yes, Nazia.
screen is not showing, sir.
It's, I think it's your, the problem is from your side, Nazia. Akhilesh
So
sir,
should
No, sir, screen is not visible.
screen is not visible.
Yes, sir.
yes.
Screen is not visible.
Look at this, not visible.
Ha, now
Yes,
Yes,
it's
sir.
yes,
Yes, sir.
visible.
Visible.
So see, I'm on this screen, so nothing will be in view.
okay,
Hello,
okay.
Okay, okay.
getting? I'm interacting with you all, so that's why this screen is off. Now it's okay.
Okay, okay, sir.
Okay, okay. Now, so it's all clear. 3 steps with every action.
Yes, sir.
Okay. Now coming back. So we have to, once your modeling gets completed, before of assigning of the load, okay, we have to check our model is right or wrong. So go to analyze, in analyze option, go to check model. In check model, you will get an option length tolerance for checks. Suppose like there are so many types of modeling error that we'll discuss. Okay, so that modeling error means what, we are going to allow the errors or uncertainties up to 1 mm. If any kind of modeling error is there, so up to 1 mm we are going to allow. That is not going to create any significant effect on your design and analysis. So that's why we are going to allow that. Then second, check for the joints. If unnecessary joints are modeled, and so many joints are modeled over another, so that all kinds of joints were checked by the software. Frame check. One, if one frame is you have model like this, another frame you have model like this. So this frame should be connected at particular joint at particular point. But by mistake while modeling you are doing what? There will be the overlapping in the frame. One frame is running over the another frame for a particular length, which is more than of your tolerance limit. Like suppose it is 6 mm. So software will show you this is what kind of error. So you have to correct it. So it is what frame kind of error. This is what shell. If you are modeling this slab and another slab you are modeling like this, like there is a overlapping of these slabs. So it is what shell overlap, and other checks are there. Okay, so these all checks we have to perform at a once. Just select all of these along with this option. You have to go to select all. Other way is what, you have to select all individually. But normally what we are doing, we are making the selection for all, and let's say simply okay. Once you click over the OK, it is checking your model and will show the like intimate that model has been checked. No warning messages were generated. It's all okay. Getting? Hello.
Yes, sir.
Okay. Now
Yes,
close
sir.
this all. So now there is no any kind of fear whether our model is wrong or right or wrong, whether the analysis will be right or wrong. So that kind of fear is vanished. Our model is perfect. Now we have to proceed for the analyzing of assigning of the load. Okay, so just drag from left to right, select this join, go to assign. In assign option, there is a joint load, frame load and shell load. So what kind of load we have to assign? Tell me fast.
Joint load.
Joint load or point load. Okay, so joint is in selection, very important. First make the selection of the thing over which you want to assign the load. Suppose I have to assign the load over this joint, so first I am making the selection of this joint, then I will go to assign and all, like similar to that of your assigning of the support. Okay, suppose I have to assign the uniformly distributed load over this frame, over this beam or over this element. So I will select the element, then I will go to assign and then look for the option. So first make the selection. Hello. Okay,
Yes.
so drag from left to right, select the joint, then go to assign, then go to joint load and then go to force. In the force option, see, once you click over the force option, a new dialog box will open under the title of joint load assignment or force. Dead load is there and live load is there. There is a detailed concept and detailed discussion will be there about the load pattern, but I will not go I am not discussing right now. That is the another thing. Okay, so if I'm discussing this, so there will be the disturbance through ongoing topic. Okay, so load pattern will be there, that we will discuss, but right now remember we have to check a live load. We are going to assign every kind of load under the live load pattern. Hello.
Yes, sir.
Yes, sir.
Now go to live load. Then over this join, if you want to assign the force along the x direction global, y direction global, or we want to assign the load force global z direction, means vertical direction. So I have to put under this direction, what is the intensity of the load?
2 kilonewton.
2 kilonewton. So I have to assign the load 2 kilonewton. So see, I am going to put 2 kilonewton. Okay, no, there's no anything we have to put extra. Let all the things as it is. Let's say simply apply. Once you click over the apply, so what kind of direction you are getting? Upward direction. But our intention is what? Whether you want to have the load direction upward or downward, tell me.
Downward.
Downward. So that's kind
Minus
of
sign.
mistake we are doing. So drag it again and select the joint, and it will be what? Minus sign in globally vertically downward direction. So put minus sign, say simply apply, so and say apply. Understood? Hello.
Yes, sir.
Yes, sir.
Clear? But what is the meaning of all these three options? Add to existing load, replace existing load, delete existing load. What it means, try to understand. Replace existing load. Okay. So whatever the load that you have assigned over this joint, drag it left to right again. So the joint is you have to select then you have to put here like -5. So option is checked is what? Replace existing load. So whatever the assignment is there, that will be replaced by new assignment. Say apply. So 2 is replaced by what? 5. Suppose, oh, by mistake I have assigned like 5. It should be 10. So change it to what? 10. But make sure that replace existing option should be checked, which will be the by default selection. Let's say apply. So see what we are getting. No selected object were found to receive this assignment. Why we are getting this kind of pop-up? Can you guess?
Member was not selected. Joint was not selected.
Yes, joint is actually not selected. That's why it will show you there is no anything which will receive your action, your assignment. Okay, So close this first, make the selection, then say apply. So 5 is going to be changed by 10. Okay, now clear this. What these two other options add to existing nodes? Like suppose after assigning of okay, undo this, okay, let it to be 10. Suppose I have to assign 15. I have to assign 15, but I have assigned 10 by mistake. So what, I can go to add existing load, and with this option I should go to 5. So what will be there? 10 plus add to whatever the existing load, say apply, so it is going to become 15. Hello, getting
Yes,
or
sir.
not?
Correct,
Yes,
correct,
sir.
yes.
Yes, sir.
Okay, now drag it from left to right again, and suppose you want to delete, I don't, by mistake this load has been assigned to this join, so go to delete and say simply apply, so that will be deleted. Okay, so normally go to replace its existing option will be by default in selection, and we have to put 2 under the live load pattern, remember. Okay, don't do the mistake, set -2, say simply first select the join and say simply apply. Is that all okay or not?
Yes, sir.
Okay.
Yes.
Shall we proceed?
Yes, sir.
Yes, sir.
Ritesh,
Yes, please.
yes sir. Sanskriti,
Yes, sir.
okay, coming back, kindly mute your mic. Now drag from left to right this join, drag from left at a time, so many number of joins you can assign the load. Okay, it is not the mandatory to assign the load only, assign the things only to one joint or one frame at a time. It is not like that. Okay, so see, on left side it is 3, on right side it is 3, both of the joints. That's why I'm selecting both of the joint at a time, joint left side, joint right side, and put the load as -3, say apply. Apply. Is that all okay? Hello, is there any another load?
Yes.
It is what reactions. Okay, don't think about it. Okay, it is what reaction, is what the result value. So is there another thing we have to assign fast?
No, sir.
No, there's no any another thing. We can proceed. So the load has been assigned. So now we are in the state to perform the analysis. Now suppose if you are getting, if you are looking here, so this grid lines is creating some kind of disturbance, right? So what I would like to do, right click on your window and click over set grid system visibility. So all the window means grids will be off. It is not deleted, it will be off, right? So it looks good, right? Hello,
Yes, sir.
right click on the window again, then click over the same option, set grid system visibility, so that will be enable. If you click over the set grid system visibility, this will be disabled. Hello, not in view. So this kind of thing you can do. Now next, after this we can proceed for the analysis. So go to analyze, in analyze option, if you want to do again check, so you can do, but we have not done any kind of modeling change, so that's why no modeling error will be there. But still if you want, we will again check the model before of the analysis, check once more. Okay, so yeah, no modeling error is there. Okay, good. Go to analyze, and here the option you will get run analysis. Your analysis will start. So many things are there that we will discuss in upcoming sessions. Okay, so run analysis, just click over run analysis, so analysis will begins. Hello,
Yes, sir.
Yes.
so your analysis has been performed. Your analysis has been performed, and you are getting this kind of deformed shape of your structure in 3D view. Let's see, this is called as what? Deformed shape of your structure. Go to elevation along the grid first. It is called as what? Deform the shape of your structure means what? Under the application of the loading, how your structure will deform. Under the application of the loading, how your structure will deform. It is what the representation. If you want to see the animated shape of your structure, so you have to click over the start animation. See, hello.
Okay, sir.
See how smartly it is showing that what on left side is the hinge support, means there is a reaction on downward side, restrain from downward side, restrain from this side. So your element, your joint cannot move in any direction, right?
Yes,
But
sir.
for the case of roller, roller is having the restraint only from downward direction, and there is no any other restraint. That's why it is moving in this direction. Getting?
Yes.
Okay.
Okay.
Up to now, from your academics, you also have seen, you also have, it is also in your imagination, like roller can move in any direction, cannot move in vertical direction. So most of you have seen this first time, roller support, how it will behave. Am I right or wrong?
Yes, sir.
Yes, sir.
Right? So see, roller can move only in this direction. Hinge will not move in any direction, and likewise fixed is also not moving in that direction. Okay, roller can move. Okay, good. So
Okay.
this is what
So,
deform. Sorry.
uh, so because of this roller support, only because of this roller support, the truss is moving.
No. Stress is moving like here. If I am assigning the
Means,
hinge support, so what vertical deformation will be there? It is not like that. Okay, unlock this model. See, if you want to do any kind of modification in modeling, because very simple, try to understand. Analysis has been done. Whatever the load that you have assigned, accordingly loads has been transferred to the members. So analysis, after the completion analysis, your model is logged. Here, see, your model is what?
yes, sir.
Logged. Now you can't change anything in this model. But as
Yes.
per your intention, you want to see any other types of the support here, like hinge support. I would like to show you. So for that, I need to go to unlock your model. Without
Yes.
of that, I can't change anything because analysis has been done. Hello.
Yes, sir. Yes, sir.
Okay. So simply say unlock your model. It will show you. Please note, unlocking model will delete all the analysis result. Obviously, right? Whatever the
Yes, sir.
result, whatever the stresses has been transferred to the members, that all analysis result will be deleted. Okay, no issue. Say okay. So yeah, it will be in the initial state, static condition. Now, just drag from left to right. This joint is in selection. Go to assign, go to join, go to restrain, go to hinge, and let's just simply apply. So the hinge support has been assigned. Now perform the analysis and let's see what's happening. What's happening? See, the deformed shape of structure you are getting. Perform the start the animation. See, Nazia,
Yes, sir. Yes.
gravitational load is also there or not? Due to that,
Yes,
the
sir.
structure will deform,
Uh-huh.
right?
Yes,
So
sir.
it is on
Yes.
large scale. In reality, it is this kind of deformation will not be there. We know, okay, but it is on large scale. Okay,
Okay. Okay.
yeah. So that is the thing. Stop animation. Unlock your model. Come to our actual state. Drag it from left to right. And go to assign. Go to join. Go to restrain. Go to roller support. And let's just simply apply. And simply apply. So this is done. Got it. After that, yes. After the performing of so support we have changed. Now perform the analysis. Now analysis gets completed. Once you start again animation, so it will deform like this and animated like this, animating like this. Say stop.
Yes.
Now we have to see the results. We have to see the result, whether your result is right or wrong. So here, in member A and B, because all the members are actually loaded member, tangential member, sorry, actually loaded member. So the loads may be, forces may be tension, or forces may be compression. It may be tension or it may be compression. Okay, so in AB, what force is coming? 6.928. In BC, what force is there? 3.46, and nature is what? Tensile. Okay, but before of that, we want to see the reactions over the supports. So go to display, go to force stress diagrams, and go to support and spring reactions. Just click over that, and in arrow format, I want to see, like, see, load case or load patterns are available here. So we have assigned the load under the live load pattern. That's why we need to look under the live load only. Check the live load. Again, I will repeat it. Go to display to see the reactions. Go to display. Go to force stress diagrams. Go to support spring reactions, and go to live load, and by the arrow format, I would like to see upward reaction only. Okay, arrow format says simply apply. So the reaction on both of the direction, both of the support, 4 kilonewton we are getting, right? Hello.
Yes, sir.
On left it is 4 kilonewton, on right it is 4 kilonewton. So the reaction you are getting right. Okay, now close this. In this way you can see the reaction. Second, we have to see the forces in the member. So for that, again go to display, then force or stress diagram. All these lines are what? Frames or shell? What is it? Can you tell me?
Frame.
Frame.
These all are the frames. So go to display, go to force stress diagram, and go to frame, pier and spindle. Just click over that, and I want to see the forces in the member as an axial force, right? Hello.
Yes, sir.
Again, so cases will be there here, dead and live will be there. We have to check live load. Under the live load, I want to see the axial forces. So go to axial forces, and rest of all things will be as it is. No change will be there. Say simply apply. Once you click over the apply, so this kind of results you will have. Hello, can we wait for 2 minutes? Hello.
Yes, sir.
Okay, wait for a minute. So the result we are getting like this: stresses in the member, or axial forces in the member. Okay, so the first try to understand by the color. So the red color is representing what? Compressive forces in the member. Red color is showing what? Compressive forces in the member. Yellow color is showing what? Tensile forces in the member. Hello. Red color is showing what? Compressive forces in the member. Yellow color is showing what? Tensile forces in the member first. And scaling. So it is what? Normal automatic scaling. If you want to see the result on large scale, go to user. It is 0.08. I would like to make it as 10 times more. So 0.8. See, apply. See. Hello. Would you like to see it like this? Hello.
No, no, no.
No, sir. No, sir.
Okay, go to this and change it to normal case. So this is what? Scale. That is thing other, nothing else. Say apply first. Second, fill diagram means by color, by the color. Suppose you don't need to fill it, let it to be as it is. So only this kind of representation will be there. And along not fill of the means this result. If you want to have the values, okay, maximum controlling values, say apply. So these results will be there. Here minus 3 point, minus means compressive force, minus 3 point, minus 4.3933. Here it is what? 1.078. Here minus 4.3933. So these are along with the these values. If you want to it to be filled, say apply. So this kind of result will be there. Hello. Okay, now if you want to see the frame result, that's you are having this kind of output. If I am making it as pier means what? Your shear wall. Say apply. Nothing will be there because there is no any shear wall. How you will get the result? So because only the frames are there, so check this frame and say apply. So you will have this result. Hello. Is that all clear about this window?
Yes, sir.
Okay. Now see how you can validate the software results. So go to your question A to B. What value is there A to B?
6.928 tension.
6.928. 6.928 kilonewton force. So but what result? Yeah, nature is same. Tensile is there. And here nature is what? Tensile. Both are same. But what the value is same or not?
No, sir.
5.19 and the result is what 6 point. Can I accept or not? Some approximation we can accept, right?
No, no,
No.
no.
Okay, see, okay, forget this. Look at this here, it is what 3.48. Go to B to C. 3.48. So here we can accept or not?
Yeah, somewhat. Yes,
Yes.
near
Partly we can accept. Okay, A to G. A to G here it is what 8.
8.
Go back. A to G here means A to G here minus 6.4606 you are getting. Hello, can we accept?
No.
Not.
Yes, not.
No. Okay, come. G to F. G to F is what? G to F 5, and let me check it. 5 here we are getting what? 4.39. Can we accept this?
No, no.
Then what? Your software giving the right wrong results. What's the problem? Why we are getting result difference? Bhushan, Akhilesh sir.
I
Yes,
think
Ashok sir.
at joints we have to release the moments because they are pin joints.
Okay, okay. Yes, correct. As I told you, all the joints are pinned joints, hinged joints. Means they should carry only the axial forces or transfer the axial forces. But in actual, when you practice with the ETABS software, and if you are making in a joint like one frame is going to rest here, means one frame is going to end here, another frame is going to end here. Okay, like this two joint, the junction of two frame ends at this joint. So ETABS will consider this joint as rigid. Hello, very important point we are going to cover. You all are with me?
Rigid
One
in
Yes.
the
frame is
sense,
like, sorry,
is it rigid in the sense fixed?
fixed one. Yes, it is considering what fixed joint. It is
No,
what considering.
it can take moment. That is
Yes, even not only the ends. If one frame is there, another frame you are taking like this. So this joint were considered by the software as fixed or rigid joint. At any way, two joints are by any way two frames are going to be connected at a particular joint. So if you are not defining anything, so the software will consider this joint as fixed or rigid joint. It means that this joint will carry the movement. Hello, this joint will carry the movement. So because here all the joints are carrying the movement, that's why it is transferring the less stresses to the member. Like see, differences you are getting, okay, that is acceptable, but always just concentrate that, okay, the forces in the software we are getting less in comparison of your manual. 6.9 you are getting 5. Why? Because joints are carrying the movement. By movement it is carrying the stresses and transferring the less stress to the member. Not getting. Hello.
Yes, sir.
yes, correct. That is correct. Yes,
Okay, because it is rigid, so some
because
stresses that should be transferred to this member, but it is not transferring by the joint. It is taking the more effort by the joint. Joint will carry the more stresses and transferring the less stress to the member. That's why we are getting the less result here. 3.48 and manual is what? 3.46.
yes, joints
Yeah.
are resisting the loads applied on them.
Yes, it is carrying the load.
Yes, they are not free to transfer the complete loads
They
to the
should be,
members.
yeah, they should be free to carry the movement. That's then in that case what will happen? Total stresses will be transferred to the member. Hello. Here it is what 5, but you are getting 4 because joints are carrying the movement and stresses. Okay, so actually the problem is what we have not fulfilled the one assumption that the joints are hinged joints. Here normally the joints are fixed joints, so that's why we have to do the modification. So unlock your model, say okay, and select all of the frames, so okay, first let me show you for one. Select the frame, one frame, then go to, sorry, clear. Select the frame, go to assign, go to go to frame. Under the frame, here release and partial fixities are there. Releases means whatever the joint is capable of carrying the movement or stresses, that should be released. That should be what? Released. Go to assign, releases, and on left hand side, we have to assign the release. On right hand side we have to assign the release. Let's just simply apply. Say apply. So on left side there is no any stresses, on right side there is no any stress. Hello, there's no any we have assigned the release on left hand side, we have assigned the release on right hand side. On both of the side releases has been assigned, so that what, it will not carry any movement, Hello, right? Hello, you all are with me?
Yes, sir.
Okay, so clear this all. Likewise we have to do for all the elements. Clear that. Select this joint frame, this 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 frame, all of this frame you have to select, and on left side and on right side select all of the frames, and let's say simply apply for all the frames. The releases has been assigned. Okay, hello, on
Should we
both of the
select
ends.
frame by frame or can we drag from left to right as a whole?
Sorry for, hello.
Should we select the frames one by one or can we drag from left to right to select all the frames at a time?
Yes, that you can do. See, undo this. Okay, see what the way. My intention is to select only the frame, not to join. So drag, so only the joint should be cut by this box, so that frames will be selected in once. Here I am dragging like this, so that will be selected. Here I am dragging like this, that will be selected. If you are trying to do like this, suppose if you are thinking in once, like so, yeah, frames will be selected, but the joints are also selected. Unnecessarily it may create any kind of modeling error, right? Hello, Akila.
Yeah, okay.
Okay, so drag it, so 3 frames in selection, drag like this, so that will be selected. No joints in selection, here. Okay, so 11 frames are in selection only, but if I am doing it means with not a care, so what will be there, like suppose this, so what, yeah, frames are, in addition to that 2 joints are also selected. Hello, so of this, clear this, select this joint, this like this, these like this, and this. So all the frames has been selected. Then go to assign. Then it is actually the frame, and we have to put something over the frame. That's why we need to go to assign. Then go to frame. Then go to releases and partial fixity on left and right. So simply apply. So this is done. Hello. Clear?
Yes, sir.
Yes, sir.
Okay. Now next. After having this, what next? Yes, releases has been assigned. Now we are going to perform the analysis. Just click over the run analysis. So analysis is going to begin. So analysis is not done. then go to display, then force to stress diagram, then frame, peer and spindle and links forces. Just click over that, and under the live load pattern for the actual forces in the member, and for all these things, let's say apply. So the results we are having now, see, just take your cursor over this, and what result you are getting? Hello, see, 6.9324. Just go back to your
Matching.
ETABS. Hello, 6.9284. Now you will accept or not, Ashok sir?
Yes, matching.
Okay, here 3.4642. Here 3.46. Now next, here it is what? Almost 5. What you are getting here between G to F?
5.
G to F 5. So it is compression, all others are in tension. So it is matching with your manual calculation or not. Your
Matching.
validation is right or wrong. Software is giving the
Valid.
correct result or not. Hello,
Correct.
is that all okay? Nazia, Bhushan,
Yes, sir.
Akila,
Yeah.
understood or not? Hello.
Yes.
Okay. Now come back. Next exercise that we have to do. There is one. Yes. Okay. So will you practice on your own for this example? Hello.
Yes.
Will you do this or not?
Yes, we can try.
Ketan. Hello.
Yes, sir.
Will you do this or not? So we'll practice for this example. Hello. Just go back to your ETABS and go to file. Just go to new model. Say no. And with third option, metric SI, it will be Indian, and still design code will be IS 800 2000 IS456. Let all the things will be as it is. First, make sure that the unit. What is the unit? Hello.
Metric SI.
Metric SI. So just go back to metric SI. Go with the metric SI. Say simply okay. Just let me know how many grids in X direction fast.
5.
5, sir.
Hello.
5.
1, 2, 3, 4, 5. It is 2D frame, 2D frame or 3D frame? What?
2D frame.
2D. It is the elevation or plan view?
Elevation.
Elevation. So along X direction, we are going to consider this along the XZ plane. XZ plane. So this is what your X and this is your Z over height. XZ plane. Okay. So just clear these all and go back to your ETABS. Along X direction, 5 grids are there. Sorry, 1, 2, 3, 4, 5. Yeah. So put it as 5 along X. And along Y, how many grids will be? 1. Okay. 1 grid will be there because actually it is in XZ plane. It is actually in XZ plane. Okay. Suppose this frame is there. Okay. Suppose this kind of frame is there. XZ plane. Sorry. This is X and this is Z. And this is what? ZY plane. This is what? ZY plane. So your frame is along this direction. Okay. So in this direction, actually, along X direction, it is what? One frame is there along this. Okay. Suppose this like this. So this line is along X. Sorry, this line is along one line is along Y. If I'm taking another line, that will be along. It is running along what? Hello. This line is running along what?
Y.
Y.
Y. So there is any one grid or not? Hello. There is a one grid.
One grid,
Okay,
yes.
just go back and put it as 1. So it will be 1. Spacing of the grids in x direction. Tell me, what is the spacing?
3.
Uniform spacing is there or not? Or is
5.
there any repetitive spacing?
Repetitive 5.
5. But uniform it is no. In y direction, put at least 1 because it will not accept 0 value. Go to custom. Kindly mute your mic is there.
So,
Okay, just go to custom, go to edit grid data, go with the second option, and for this case here A to B it is 5, B to C it is 5, and C to D it is 5, then D to E it is 6, D to E it is 6, and last it will be 0. Along Y there will be nothing, let it to be some dark color like this. Say okay, say simply okay, say simply over the height. How many levels are there, can you guess?
Three.
How many? Sorry,
Three.
3.
Three levels, sir.
how?
Uh,
F, G, and H.
eh,
Sorry,
Level F, level G, and level H.
label level A
how
F
many
G.
levels are there? Levels.
G F A. H is Hana
All are
base.
levels like this:
Okay.
first, second, third, and four. 4 levels are there. But you don't need to consider this base one because ETABS will by default give you it is as base level. Hello, right? So only these 3 levels you have to consider: first, second, and third. 3 levels, extra levels are there except your base. We are going to put here 3. Base will be by default there. Typical story height. Okay, before of that, we need to know all the heights, all the story heights, all the levels heights. At this level from here to here, and last from here to here like this. Can you guess how we can calculate it? Is there any way? Sufficient data is there or not to find out these heights? Okay, first find out this height. Then we will find out this height. Then finally we will find out this height. From top we are going to calculate. Tell me how you can calculate this height?
By similar triangles.
What similarity of triangle? Yeah, that is also a way to find out by the case of similarity of triangle. Okay, good. We can proceed like that. Total height for the big triangle is the big triangle, right, Nazia? Hello. Height divided by base length. Height divided by base length. Hello.
15.
Is 15
Yeah, 10.
is
10
equal
theta.
to first we have to okay, first find out this one, okay, first at C. So this will be what? Height, that is the question. This I am going to call it height first. This I am going to call it as height 2.
We
So
can use tangent equation, tan theta. Case of
no
one bit.
sir, that is also okay, but instead of that we can directly calculate by this similarity of
Yeah,
triangle.
yeah. Right.
Both
Yes.
options are there. It may be easy. It will be easy. H2 divide by what? 10. Okay. So H we have to find. So H2 will is equal to 8 multiplied by 10 divided by 15. Just give me answer. 80 divided by 15. Give me answer. Calci should be in your hand every time.
5.33.
Sorry.
5.33.
Here you are getting what? H2. H1 is 8. Sorry. H1 is your 8 meter. H2 by calculation you are getting what? 5 point? Hello.
5.33.
5.33. 5.33. H3. What you are getting H3? See, what is the formula of H3? For calculating the H3 value, it will be what? 8 divided by 15. H3 divided by this H3 will be H3 divided by 5. Right? Hello. This span. This span will be 5. Okay. So it will become 8 multiplied by 5 divided by 15. That will give you H3 value. H3 value. Give me answer H3.
2.66.
H3 value you are getting 2.66.
66.
You are getting 2.66. Okay. Now just let me know. Actually H3 this height we are having. So we need to have actually very simple. First try to understand. Actually we have to know the height from base, not from top, and for every level. So from here to here, how you can get from here to here? Hello. So H2 it is. It is H2. It is H2 and it is H1.
40.33. Yes.
So how you will get this? So this
8
value you will
minus
get from H2,
8 minus
H1 minus H2. What is the answer? It will
8
come.
minus 5.33.
It will again come to 2.66. Hello. Check it. Right or wrong? Hello.
Right, sir.
Okay. Now this height you will get like by the difference of H2 minus H1. It is what? H2 minus H1. What is the answer you are getting? 5.33 minus 2.66. You will again get 2.66. Am I right or wrong? Hello. 2.66. And last one is still 2.66. So all the heights are actually what? Same. Right or wrong? Hello. You all are with me.
Yes,
Yes,
sir.
sir.
Go back to ETABS and typical story height will become what?
2.66. 2.63.
2.66.
2.66.
Okay,
Yes.
2.66. Bottom story height will also be 2.66. Put it as 2.66. Okay. Go to custom if you are having any doubt. Go to edit story data. Let's see. These are level first and this is what level 2 I can write. This is I can put level 3. So this is all done. And see total finally you are getting what? 7.98. Actually cumulative height total elevation height should be what?
8.
Hello. 8.
8.
So I would like to put here 7. Put here 7. Put here 7. So enter. So it is approx. Now it is right or wrong?
Right, sir.
Okay. So simply okay. And let's say simply we need to have the grids. Check this grid. Say simply okay. This is all done. Clear this all. This is a 3D view. This is a plan view. Now close this. Actually, we need to have only the elevation view along the grid first. Go to elevation along the grid first. Say simply apply. So we'll have this grid. Hello.
Yes, sir.
Now we have to model that. So just go to frame, close this, and see. First select on this first point, drag it to this point. Okay, okay. Undo this. Go back. Vanish this command. Go to frame. First click over the frame. close this and look at this. Yeah, from this point to continuity of the frame is there along this line. Okay, so go back to your ETABS, take the frame option, this dialog box will open, close this, then click over this first point, come to this next point, take the benefit of the continuity, click over that point, come to this side, click over that, then come to this side, click over that. Okay, now here you have to click. Now this is done. From 3 to you directly have to come to this side, right? Hello, but it is the
Yes, sir.
base level. So what will happen if I am going to click here? Hello, like if I am going to click here, so the software will by default assign the support to this joint. Click here, so yeah, it is automatically assigning the hinge support to this joint, then coming back to this joint and then click over that. So this is done. Hello, right?
Yes, sir.
But the problem is what, we actually have to divide all these frame to these joints. Hello, so okay, let it to be, later on we will discuss, we will talk about how you can divide it. So go to frame, so close this, from this point to this, click over that, right click to off this continuity. Now from this joint to this, click over that, right click. Now from this point to this joint, click over that, so the frame will be modeled. It is done. So all the frames has been modeled except this inclined one from F to C, from G to D. Just go back to your ETABS and go to frame, close this, from this joint to this point, one frame, right click, from this joint to this joint, this point, right click over that, so this frame will be modeled. Understood? Hello.
Yes,
Yes,
clear.
sir.
Now
Sir.
here the problem is what, all the frames are okay. Problem with this frame, because it is we have modeled from this joint to this joint, so it is right or wrong?
It is not correct. You have to
Not
divide
correct, we
the
have to divide it. So
three
drag it
parts.
from left to right, make sure that one joint is there, drag it from left to right, one joint is there, two joints, one frame. Go to edit, go to edit frame, go to divide frame, go with the second option, break at intersections with selected frame that we have done, with selected joints that we have done, say apply. So yeah, it is going to be breaked, it is going to be divided. Understood?
Yes, sir.
Okay, now clear this all. On the bottom side, there is a roller support, but the software by mistake, means by default has been assigned hinge support. So what we have to do, we have to change it. So drag from left to right, one joint is the selection, go to assign, go to joint, go to restrain, and here the roller support should be what, roller. Check this roller, say simply apply, so the roller support has been assigned. Then drag from left to right, this joint is selected, go to assign, go to joint, go to restrain, go to hinge support, say simply apply. So here it is hinge, here it is roller. So all these supports we have assigned. Is that all clear?
Yes, clear.
Yes, sir.
Understood?
Yes.
Yes, sir.
Now what thing is remaining? So after completion of modeling, so we don't need to have these grid lines. I am going to right click, go to set grid system visibility, so the grids will be off, only your model and assignments will be there. Now perform the go to analyze, go to check model and select all of these options, say simply okay, and let's check is there any modeling error or not. What intimation and what notification you are getting? Hello,
No error.
model has been checked, no warning messages were generated, means your model is okay. Now close this. Now go to we have to assign what, load. What kind of loads are there?
Axial
Point
loads.
load.
Hello.
Point load, sir.
Point loads.
Only the point loads are there. So go back to your ETABS and drag it from left to right. The joints are selected. Joints is selected. Go.
Sir,
How much
I
load
have
is
a
there?
doubt.
14 Newton. Hello.
Excuse me.
Yes.
Sir, between A to D, should we not divide the frames?
A to D.
Should we not divide the frames?
Actually, we have modeled it separately already. Not it is not single frame. Hello. See, all the frames are
Okay.
separate. Hello.
Okay.
Okay. So why it is needed to divide it? Akila, understood?
Okay. Okay.
Good. Okay. Now clear this all. Drag from left to right. Select the joint. Okay. Let's see. The unit is what Newton, but we have to assign the load under the means with the unit kilonewton. So how much it will become in kilonewton?
By 1000 divided by 1000.
Divide by 1000. How much it will become? I think
0.04.
0.04. Right? Hello.
Correct.
0.04 kilonewton we have to assign the load. Okay. Remember. So go back to your ETABS. So drag from left to right. Then go to assign. Go to joint load. Go to force. And under the live load pattern with the global Z direction vertically downward. So that's why we need to put minus sign. Otherwise it will be upward. Okay. Put minus sign. Don't forget to put minus sign. And 0.04 because unit is asking about 40 means kilonewton. Let's just simply apply. So yeah, 0.04 kilonewton has been assigned to this joint. Drag from left to right, select this joint. Make sure that one joint is selected. Most of you, when you will practice, you all are with me.
Yes.
Yes, sir.
Yes, sir.
Most of you, when you will practice this example and when you are dragging from left to right over this joint, so you will get 3 joints, 4 joints, 5 joints. Hello. Actually, it should be 0. Sorry, it should be 1. But when you drag from left to right, so how many joints will be selected? Should be selected 1 only. But you will get 5 joints, 3 joints. Means what? You are doing the mistake while making the while clicking over the joint. When you are practicing as a beginner, so this kind of things will happen. Okay, acceptable. But remember, this will happen. It means that your model is means you are doing wrong. Hello. Hello.
Yes, sir.
Okay, so take care about take care of this. Okay, select this joint. Now just go back. That's why how you can means control this kind of error. So while making selection, clicking over the joint, very clearly means you have to click over that joint. Okay, don't do the mistake unless and until you are not getting the red sign for the selection. Don't click over that. Okay. So yeah, here how much load is there? 24 Newton. So how much it will become? 0.024? 0.024. Say apply. Okay, hello. It is showing up to the 2 decimals. That's why 0.2. Otherwise the assignments are same. Oh, assignment is correct. Hello.
Yes, sir.
Is there any assignment is we have to do? Hello. Is that all okay?
Can I ask one question, sir? Can I ask one question?
Yes, sir.
Like in the question, the figure is numbered like A, B, C, D, E, F. Can we put those numbers in our model?
ABC. That is what a grid. I can say the grid level. Right click, say grids.
Actually, similarly, we cannot put the same numbers
No,
the
no.
same
Why?
time.
Why it is needed, sir? Actually,
Okay.
why it is needed?
Hmm. Not required otherwise, yes.
No, yeah, it is not needed
Technically not
actually.
required.
Yeah, yeah. Actually, it is not needed. Right click and set grid system is ready. Understood? Hello. Yeah. See, once you like once you are doing anything, the loads are not showing here. It means what? Loads is deleted. You have to assign again the load, right?
Yes, sir.
Where is the load? Hello. We have to assign again the load. Hello.
No, sir.
Why? Actually, the
I
load
think
is there, that is not in view only. Remember, it is not the case. Load we have assigned, load is there, doing when you are doing other things, that loads will be means not in view. Actually, if you want to see your assignment, so go to display, go to load assigns. Display means what things you want to see on your display. Display means what things you want to see on your display. So go to display, go to load assigns, go to joint assignments. Joint assignment, we have assigned the load under the dead load or live load. Tell me fast.
Live
live
load.
load.
Live
Live
load.
load. So go to live and say apply, because in dead load there is no any kind of assignment. That's why no option is there. Apply, only close is there. Nothing operable. So all are in active form. So go to live. Say simply apply. So the loads are there. Akila, Ashok sir.
Yes, sir. Correct.
Okay. So it is not the case. Don't worry. Okay. Close this. If I'm say undeformed shape means normal setup, normal model, only the normal view of the model. So see, all the things, all the assignments will be off, but it is the meaning that the load has been deleted.
No,
Sanskruti,
no. No, load is there, but not
Sanskruti,
visible now.
what it means? It is the means that load has been deleted. Okay, coming back to your ETABS. Now, after this, the loads are there actually. Okay, now perform the loads has been assigned, supported has been assigned, modeling has been done. Now perform the analysis. So it is asking to save your model. Say 002. Say save your model. So yeah, this is what deformed the shape of your structure under the application of the loading. If you want to see the animated shape, say start animation. Okay, but one thing we missed, that what we have missed to assign the releases. Because otherwise your result will not match. So unlock your model. Okay, and select all the frames. Select all of these frames. Select this frame, select this frame, select this frame, all the frames is in selection, then go to assign, then go to frame, then go to releases and partial fixity. On left hand side, on right hand of side of all the frames, say simply apply. So the releases has been assigned. Now all the joints are hinged or pinned joints. Now perform the analysis. Analysis will start, and it will show you result. Okay, deform the shape of your structure. If you want to see the animated shape, you will get the animated shape of your structure. Say stop animation, then go to display, and display, then force stress diagram and support reactions, and under the live load pattern, with the arrow format, in z direction, say apply. So you will have the reactions. Okay, but here we don't need to see the reaction. We have to see only the stresses. Okay, or actual forces in the member. So go to display, go to force stress diagram, go to frame pair spindle and links option, and under the live load pattern, make sure that you are under the live load pattern. By default it may be dead, so you have to change it to live, and then go to axial load, axial forces in the member, and automatic fill diagram. If you want to see the values also along with the diagram, check this option. Make sure that frame option should be checked, and it will be actually by default. Let's just simply apply. Once you click over the apply, you will have the result like this. Hello.
Yes, sir.
Okay. Now come back to your this file. A to B, B to C, C to D, and D to E. The forces are 30 kilonewton tensile nature. So yellow color is showing what tensile nature. Here see 0.03 Newton. So how much it will become? Sorry, kilonewton. How much it will become in Newton?
30 Newton.
30. Here it is 30. Here it is 30. Here it is 30. Validate. Results are validated or not?
Yes, it is.
Validated.
Okay, now here it is what 34 34 34 kilonewton. Just go back. AF AF FG GH 34. BF, CF, CG, GD, all internal. Let's see. Here it is 0, here it is 0, here it is 0, here it is 0. All these are 0. For this vertical one, DH, DH24. Look at this. Exactly 24 or not?
Yes, sir.
Here it
Yes,
is what?
correct.
50. Here it is what? 50. Just go back to
Exactly.
your result and 50. Is that all okay or not?
Everything is
Yes,
okay.
sir.
Okay, sir.
Yes.
So your result is giving. So along with all these this validating exercise, you are getting so many things. How you can divide the frame, how what is the making procedure of making the selection, and how to look what the things are in selection, how to assign the loads, how to assign the releases, so many things. How to see the reactions, how to see the actual forces in the members, how to make the assignments of the loads in the view, how to off this, how to make the grid lines to be visible, how to make it invisible. Are you getting? Hello.
Yes, sir.
Understood. Shall we proceed now?
Yes, please.
Yes, sir.
Okay. Unlock your model. Say okay. Come back to your this. Now next, this for this will you do this or not on your own? Hello.
Yes, we'll do.
Okay. So you have to do this. Only thing is what? How you can assign this kind of horizontal load. So let me show you. Suppose you are coming to this. Suppose I have to assign the load to this joint as horizontal. Hello.
Correct.
So select this
Yes,
In
sir.
joint. Go to
y
assign.
direction.
Go to join load. Go to force. Can you guide me how I can assign?
In the y section, y direction.
Y or X?
X direction.
Uh, X.
Why, sir?
It should
Why
No,
Y?
be.
no, 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 no. Sorry, sir.
It should be in X.
X. X. How much it is? 30 kilonewton. So how you can assign this in X direction? Put it as 30. Okay. Positive or negative?
Positive.
Positive. Okay. In right direction, if you want to have the direction, positive, right? If you are doing, suppose, oh, by mistake, it should I have assigned it right side. It actually should be on left side. So again select this and replace the option. You have to put minus sign. Just say minus sign. Let's say apply. Right? Hello. Will you do this on your own? Hello.
Yes,
Yes,
sir.
sir.
Yes, we'll do.
Okay.
Yes, sir.
So I'm going to left it for your practice. So this is for your truss. Okay. Now come to like another element, beams. Hello.
Yes, sir.
But before of that, some important things we have to understand. You all are with me. Very important things I am going to take.
Yes, sir. Yes, sir.
Okay.
Yes, yes, please.
Actually, as in the previous session we have seen that there are different axis system, global axis system, local axis system, natural axis system. But in our for a use, global and local axis is enough. Okay. So actually, suppose if you are talking about the beam, okay, like suppose the beam is like this. Especially I'm talking about the beam, not other element. Forget all other elements. Only we are going to talk about the beams. Okay. Suppose the beam is like this and it is having its local axis system. Local axis system. Hello. Hello.
Yes,
Yes,
Yes, sir.
sir.
one, two, three.
Okay. ETABS software is showing global axis by the Cartesian labeling like X, Y, and Z. Hello?
Correct.
X, Y,
Global
and then
by
take the
XYZ,
3D
right?
view. Take it downside. Cartesian format X, Z, and Y like this. But when you come to any particular element, if especially about the beam, so this axis is what? It is global. It is what?
Local.
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 So local axis is represented by the numbering. So here it is showing what? Axis 1 1, axis 2 2. Sorry, this along Z axis 2 2, along Z axis 2 2, and this third axis is showing by the axis 3 3. That is out of the plane. Considering we are considering what? It is out of the plane normally. Okay. Now simply try to understand. If I want to see the axial force in this beam, so which axis I need to look?
3 3.
Sorry,
1 1 1
beam is there. It is the line element. Axial force means what? The force which is along the longitudinal direction of the element. Like suppose if you are talking about the column, let's see column. Suppose the column is there, and so column is like this. Okay, and this is what? This is the longitudinal axis along the longitudinal direction, along the long span of the column. So the loads, this load we are going to call it what? Axial force or not? Hello.
Yes, sir.
Axial force.
Okay. So for the case of beam, it is the same case. If the beam is having the load in this direction, so that is what? Axial force or not?
Yeah, axial force.
It is what?
Yes, sir.
Axial. So in case of beam, if you want to see the axial force, you need to look along the axis 1 1. Hello.
Correct.
Yes, sir.
Along the axis 1 1. Got it? If you want to see the force in the beam element along the axis or axial force actually, so you need to look axial direction as 1 1. But if you have to see the forces like along the depth of the member, so you need to look axis 2 2. And
Yes.
see, this is the third axis which is out of the plane. If you want to see the movement, so you need to look axis 3 3. For the case of the beam, not getting. Okay, come here. Let's see. First tell me, a beam is what? Either flexural element, compression element, or axial element which is carrying only the tensile forces. Tell me what?
It is lecture.
It is the flexural element and which will be subjected to only the transverse force. Transverse force means what? The force which is perpendicular to your longitudinal direction, right? Longitudinal axis. So it is perpendicular. Am I right or wrong?
Correct.
Yes, sir.
This is support.
Yes, sir.
So your beam is your flexural element which will be subjected to only the transverse forces. Which will be subjected to only transverse voltage, transverse loads, and this beam will not carry the axial forces except the exceptional cases. Hello.
Yes,
Your
sir.
Yes, sir.
beam will not carry axial forces or the forces along the its longitudinal direction, that is 1 1, except the exceptional cases. Yeah, in some cases your beam may carry axial forces, but it is very I can say exceptional case that I'm not going to discuss, in which case you will get the actual force in the beam. That is another discussion it will be if I'm going to start. Okay, so your beam will not carry the actual forces. Your beam will carry only the transverse forces, first thing. Second, so you all got, if you want to see axial force, you need to look at 1 1. But under the application of the loading, so your beam is going to carry the reactions like this. Over this reaction, over support, over this reaction, you are getting this reaction. So due to this reaction, what this we are going to call as shear force, right? Hello.
Yes, sir.
Yes, shear force in 2 2
We are going to
axis.
call it a shear force diagram for the beam. You might be solve the example for finding out the shear force diagram. So the shear force diagram for the beam will be like this. If it is simply supported like and point loaded, so the shear force diagram will be like this. Am I right or wrong?
Yeah, support and change in midspan.
Okay, so it is having the shear force diagram, and under the application of this load and due to this shear force, what will be there? There will be the shear development of shear cracks like this. Hello. What will happen under the application of the load and due to reaction? This actually this is another part I will take in detail at the time of design, detailing, scheduling of real life project. But some part just try to understand here. Here there is a support. This part of the beam is having the stiffness. Hello. Stiff support from the downside and the loading from the top side. So this part will not go anywhere. It is stiff. It is stable enough. But this is the cantilever part and the load is coming. So over this joint, it is going to it is lagging its stiffness. It is lagging its strength, and due to heavy stress and there's a suddenly loss of contact surface, there is the possibility of development of crack, and that crack will propagate along the depth of the beam. Okay, along the depth of the beam due to this shear force, heavy intensity of the shear force from this side and from this downward side, this crack is developed, and this crack is propagate along the depth of the beam, means the due to shear along the depth of the section. Hello. So that's why whenever I'm going to say you like go to look how much shear force in the beam, so which axis will you refer?
2 2.
You all should answer. Hello. 2 2. Clear? ये बहुत important point है. Most of the time students are confused. What does it mean to access 2 2, or trainers they tell just say if you want to see the shear just go to 2 2. Okay. If you want to see the axial force just go to 1 1 then over. But what is the reason? So I hope you all means come to know what is the reason why you are looking 2 2. Hello.
Yes, sir.
Yes, sir.
Understood, Chandradev?
Yes. Yes.
Yes, sir.
Okay. Now coming back to ETABS. Okay. So one thing is clear. Along 1 1, along 2 2, along 1 1 will be axial, along 2 2 will be shear. What about along 3 3? That is the third axis about which we have to see the movement. About which we have to see the movement. Like there are three equilibrium equation. Summation f of x. All the forces in x direction means along the longitudinal direction of the member beam, along this direction. Summation f of y, that is all the forces along the y direction, means along the depth of the member for the particular beam, so along depth. And third axis is what? Third axis is x, it is y, this is z out of the plane. So this axis will be out of plane, about which we have to calculate the movement. So that will be what? Out of the plane axis 3 3. Hello. Understood
Yes,
or
sir.
not? So the conclusion of this overall discussion is what? If major axis for shear force is what? Hello.
Along 2 2.
2 2. And minor axis for shear force is what?
3 3.
3 3. Now next, major axis for movement, what it will be?
3 3. 3 3.
3 3.
Major.
Major axis. And minor axis for movement?
2 2.
2 2. So it is not the case that major shear force will be 2 2, so there will be no any shear force is along 3 3. Yeah, shear force will be there along 3 3 also, but that is not significant. Actually, for the design purpose, for the shear force we need to look axis 2 2 for the beam, and for the movement we need to look axis 3 3 every time for the movement, and there will be the movement along 2 2, but that will not be much significant. Getting or not? Actually, we have to model this beam. You all are with me?
Yes, sir.
Okay. Just tell me what type of it is. What type of this beam?
Cantilever.
Cantilever beam.
Okay. What
Cantilever.
are the different types of the beam? What are these?
Cantilever,
Simply
simply supported
supported beam,
cantilever.
fixed beam.
Yes, Sanskruti. Or
Cantilever beam, fixed beam, simply supported beam.
okay. Continuous beam,
Continuous
fixed
beam.
beam, cantilever beam, simply supported beam, overhang beam, or कौन सा है? Is there any other one? Yes.
Inverted beam.
That is based on structural behavior and positioning. That's another thing. Here we are talking about the support condition. Ketan, you are correct, but that is another way of defining the beam. Okay.
Okay.
Yeah. Here I'm asking about based on support condition. Akhilesh sir.
Yes, sir.
What are the different types of the beam?
Simply supported, continuous, cantilever.
Okay. Okay. There's no any other type of beam. That's it.
Transit,
Prop
sir.
the cantilever. Have you heard about prop the cantilever, Sanskruti?
Yes, sir.
Have you heard about?
Yes, sir. We heard.
Okay. So what does mean by the prop the cantilever? Okay, we will take it later. That's another thing. Come here. So it is what cantilever. Just tell me. How many grids will be in X direction?
4.
Yes. All you should take. Give your opinion. Hello.
Four,
What should
sir.
be the grids? Hello.
4, sir.
4. Ketan. Bhushan.
4x1.
Sorry.
1, sir.
1. Okay. Bhushan.
Yes, sir. 4x1.
4 by 1. Okay. So it will be along X4. It is the elevation view as similar to that of your truss. Okay. So go back to ETABS. Kindly mute your mic. All of you are requested that kindly mute your mic. Go to new model. Say no. Go with the third option. Edit metric SI system. Let all the things as it is. Say simply okay. In X direction it is 4. In Y direction it will be 1. And spacing. What spacing is there? Can you guess? Can you tell me? 0.5. Uniform spacing is there or not? No. So let it to be as it is. Make it as 1. Go to custom grid. Go to edit grid data. And go to display grid data. Sorry. And it is what? 0.5, 0.7, 0.8. 0.5, 0.7, 0.8. Is that all okay? Hello.
Yes, sir.
1000. Grid color will be some dark color. I would like to take. Say okay. Say simply okay. And what about level? Is there any need to worry about level? Hello. Is there any need to have the level?
No.
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 Only one level is there. But yeah, still I am going to take here as one extra above the base, and height we don't need to worry about. Let it to be. Go to edit grid data. Say simply okay. Now close this. Base level is there. Okay. Elevation. Go to elevation along the grid first. Say apply. So two levels are there. One is base. One is your first level. So where you want to work, either you can work on base also. You can work on story 1. Problem is what? If you are working on base, so it will automatically unnecessarily going to assign the support, right?
Yes, sir.
Hello.
Yes, sir.
So we will go to work on story first. Agreed or not?
Yes, sir.
Okay.
Yes, sir.
Agreed.
Now we have to start for modeling of this beam. So go to frame, close this frame, come here. This is the first point. Come to this. Come to this. See, most of you think that why we are taking it is first. Tell me, it is one beam or continuous beam or two beam. What is it?
Only one
One
beam.
beam, sir.
One
One
beam.
beam.
So most of you may say that why we are taking it to be braked, why we are not modeling like from this first point to directly this point. Am I right or wrong?
Yeah, that is,
Yes,
yeah.
sir.
Right, sir.
I intend to ask you this question. Yes.
Yeah. So why we are doing this, or for that, why we are taking so many grids? Two grids is enough, left and right. But the problem is what? If you are taking it from this point to this point continuous, you will be getting in trouble to assign the load actually. Hello. What? See, I'm dragging from left to right. I'm not able to catch the joint. I'm not able to click the joint. Then how we can assign the load? Without of making the selection, can you assign the load?
No.
That's a problem, Ashok sir.
Correct. Understood. Yes.
Getting? So come
Yes.
back. So that is the problem. That's why what I'm going to do, I'm going to model it. The frame, close this. The first point, move to this joint, move to this joint, then move to this joint. Now let's try to select the joint. Drag from left to right. So joint is selected, right? Drag from left to right. The joint is selected. Now it's okay.
Now correct. Yes.
Good.
We can
Is
apply
that
load now.
okay? See, being this joint is selected, okay, so you can assign the load. Am I audible or not?
Yes, sir.
Audible.
So
Yes, sir.
why most of you are not answering? You should answer instantly when I'm asking. So I'm getting you are understanding the thing or not. Hello,
Okay, sir.
Ketan.
Yes, sir. Sir.
Okay. Okay. So first we will assign the support. Then we will look at other things. Drag from left to right. Joint is selected. Can anyone guide me how I can assign the support? Fast. This example you have to do. Okay. Tell me. Just guide me how I can do. How I can proceed fast.
Go to assign.
Select the joint fast.
Yeah.
Okay.
Go to assign.
Okay.
Yeah. Joint. Yes.
Okay.
Restrained.
Okay.
Fixed.
Which one? Second one, third one, first one. Which one?
First one. First one.
Select this first. Then
Cantilever fixed. Yes.
then
Apply.
apply.
Oh,
Okay. Then
yes.
is there
Close.
any other support we have to assign?
No.
Can I close this window?
Close. Yes, please.
Yes, sir.
Okay. This done. What next step will be fast?
Apply loads at the
Applying
joints.
load.
Directly apply load.
Select the joint.
No. Directly go to assign the load.
Check,
Or
sir,
you are
model.
missing something.
Check model.
No.
Check model, sir.
Okay.
Select the joint.
Again doing mistake, sir. Hello.
Uh-huh.
First check the model.
Check the model. Okay.
Go to analyze, go to check model, select all of these options. Along with this, say okay. Let's check whether the modeling is right or wrong. Okay. Now close this. Why I'm checking the model before of assigning the load? Actually, you can check your model after the assigning of the load also. You can check your model after the assigning of load also. Okay, that is the one thing. But why I'm saying that go to check your model before of assigning or after the completion of the model? Because suppose if you are getting some kind of error, and due to that error, if you are feeling to delete this frame, so your work unnecessarily will be lost. Like you along, suppose I have assigned the load over this joint, so the frame will also be deleted and joint will also be deleted, and along with that, unexceptionally, your load will also be deleted. Hello.
Correct. Yes.
So आपका work effort unnecessarily loss हो रहा है ना? Hello.
Sir.
Right or wrong?
Right.
That's why first make sure that your model is now finally okay. Then go to assign so that there will be no any issue. Getting? So clear this all. And after that check your model. So model is now okay. Then go to select this joint. Select this joint. Both of the joint. Let's see what intensity. Yeah, intensities are different. So clear this. Select this joint. Then go to assign, then go to joint. Okay, can anyone guide me how can I assign the joint load fast? Yes, Sanskruti, you should guide. Hello, tell me fast.
Go to assign.
Directly go to assign.
Yes.
Directly.
Select the joint.
Okay.
Select joint. Go to assign.
Okay.
For joint load,
Okay.
force,
Okay.
live load,
Good. Very good. Very good.
in Z direction.
Yes.
What is the load?
Okay. Let me check. 300 Newton. Then
0.3 kilonewton.
yes. Yes. All right. 0.3. Okay. Then
Then apply.
Okay.
Select another joint. Next joint.
Your assignment is correct.
Minus 0.3.
So then what I can do?
Replace existing load, and you can change into minus 0.3.
Okay, that is the way. Otherwise, you have to go to undo this step. Okay.
Okay.
Say apply. Now it's correct. Select this joint. Then
Mm,
minus
minus
point.
0.5.
Okay. Say apply. Then
Select another joint and 0.8. Minus 0.8.
minus 0.8. Let's just simply apply. It is done. Okay. Hello.
Yes, sir.
Okay. So close this. This is all done. Is there
Yes,
any
sir.
need to have these grid labels and grids?
No, sir.
Right click and set grid system visibility. So your frame will be there only. Understood or not?
Yes, sir.
Yes, sir.
Okay. Now, can I perform the analysis?
Yes, sir.
Yes. Just click over the run analysis. Your analysis is going to start and just put it here. It is asking to save your model first. Okay, save your model by any name. Analysis will start and you will get this kind of result and say start animation. So this kind of animated shape you are getting. It is right or wrong?
Right, sir.
Right. Okay. Stop animation. And I want to see the movement in the beam. Okay, and shear force diagram. Shear force I have to validate and bending moment I have to validate. So go back to your ETABS. How I can see? So go to display force stress diagram. Support reaction, if you want to see that you can see, but we are not interested to see that. Go to frame peer values or stresses and forces, check this option and see under which load pattern, live load pattern. First I would like to see shear force. Hello, first I would like to shear force diagram or shear force value. Tell me how I can see. Okay, ETABS software is not representing the longitudinal direction as by 1 1. It is directly given as axial force, but you can say it is axis what 1 1, right? Hello.
Yes, sir.
Hello. Okay. Now if I want to see the shear force, which axis I need to check?
Shear 2.
Axis 2 2. Okay, check this option and say simply apply. Hello. If you want to have the values also, check this option, say apply. So here what value you are getting? Hello. 1600 Newton. Why you are not answering?
Yes, sir.
1600. Go back to your ETABS. Here what intensity?
1600.
Right or wrong? Software is giving right result or not?
Right, sir.
For this frame, how much you are getting? 1600 minus 1300. How much it will be?
1300.
1300. Go back to your ETABS. Check here whether you are getting 1300 or not.
Getting
Getting. In last 1300 minus
800.
500, it is 800.
800.
Go back. Let's check it is 800. Hello.
Yes, 800.
Okay. If you want to see
Correct.
movement, which axis you have to refer?
3.
3 3. Okay. Check this option 3 3. Say apply. The bending moment diagram you are getting. Negative bending moment you are getting. Red color is showing what? Negative bending moment, or you can say hogging moment, and yellow color is showing what? Sagging movement and positive movement. Will you remember this? Red color is showing what?
Hogging movement.
Hogging movement or negative movement. And
Yes,
yellow
sir.
color is showing what?
Bending
Sagging,
moment.
positive.
Sagging and
Oh,
positive. There is a very important discussion about it. We will cover it later. Okay, but remember this thing. Okay, yeah. So this is done. Next, after this, what I have to discuss. Okay, movement is now there, but if you want to see the more, okay, for the movement we have to validate it first. Okay, go back, see on left side 2.35 kilonewton meter, actually it is 2350 in newton meter, so in kilonewton 2.35, look at this 2.35, right or wrong?
Right, sir.
Right.
Right.
Here it is, we are getting 1.55 for this. Go back, look at this 1.55. Hello.
Correct.
Here 0.64. Go back, check here 0.64. Hello.
Excuse me, sir.
Yes.
In which situation we will release all the moments at the joints where we had applied the loads?
Sorry.
We had applied loads at 3 locations, right?
Okay.
Only at trust locations. In trust members only.
Wait. Ashok sir, wait. Yes, Akila.
We did not release the moments
Actually, that was the assumption for the truss analysis only, ma'am.
only. Okay.
Don't mind, ma'am. In your academic, you might be solve this kind of example truss. Have you remember that?
Okay.
Okay. So they or open any book. Okay, let me show you. See, weight of the member. Is it visible?
Yeah.
Weight of the member can be neglected. All members have the uniform section. All external forces are applied at the joints only. All members have the axial forces only. Members are connected at the joint through pinned connection only. Hello.
Okay.
Or hinge connection. That is for the case of only the truss analysis, not for others. Hello.
Okay. Okay.
When you are going to analyze the truss, for that only, for all the frame at all the ends, you have to make it as pin connection or hinge connection. Understood? So forget that concept. Now we are coming to beam. Hello. Akila ma'am.
Yeah. Following.
Understood?
Okay.
Okay. So forget that concept. That is for only the truss case.
Okay. Thank you.
Okay. Yeah. It is now we have started the beam. We have started the beam. So yeah. So all the movements are means matching with your manual calculation. Agreed or not? Okay.
Agreed. Yes.
Okay. But if you want to see the more elaborated result, so just take your cursor over the element and right click over that once more. If you want to see the more elaborated result, just right click over the member, so you will have this kind of result. Hello. It will show you all these values in once. Shear force 1.6 for this member, and on left hand side what value of a moment is there? 2.35. If I am taking my cursor and dragging from right side 1.55. Hello. For
yes, sir.
this member, and shear force is same from left to right. At any point you can see the value. Is suppose at mid, suppose whatever the length is there, it is from 0 to 5, 0 to 0.5. Okay, in between I want to see 0.25. Say enter. So now at the center, what the value? 1.95, and shear force is same. Getting or not? How smartly you are getting the values at the mid of this span? Hello. Shear force on the same screen, you are getting shear force and you are getting movement. Previously here you are able to see only one thing at a time. Hello.
Yes, sir.
But if you want to see both of the things, just right click over the member, so you will have the more elaborated result. Shear force in one window and movement in one window. So on left hand side 1.55, on right hand side 0.64. In between, if you want to see the result, so see what is the span of this beam. this part 0.7, so half of 0.7 will be 0.35. Put this, so at a particular span, a particular section, you will get the value. Understood or not?
Yes, sir.
Okay, so this is about what, how you can model the beam, and how you can see the result, and how you can validate this result. Are you getting or not, you all? Ketan?
Yes, sir.
Okay, but actually what it is, very basically, by the basic way we have executed this example. But if I'm saying that, okay, we have model it in parts, but that is not needed. We can assign the we can model this beam as a single element from left to right, and we can assign the load, joint load over the frame. Hello, the problem that we have faced, that we can tackle. Hello, that we can
Yes, sir.
tackle by modeling single beam. Would you like to see that?
Yeah, please explain, sir. How?
Okay, so that we will see by tomorrow. Okay,
Okay. Okay.
okay, so it is not hard and fast, just for your understanding I am discussing it and creating the situation. Okay, that you can model it as a single element, and then you can assign the point load. That is the another case that we will cover by tomorrow. Okay, hello.
कसं असतं